Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering. It is an autonomous institution located in Hyderabad, Dundigal, India. Today we are going to discuss about degrees of freedom. It comes under the module 1 of the subject Kinematics of Machines. So what is degrees of freedom of a body when it is in space? Before going to discuss when the body is in space, what is exact definition of degrees of freedom? The degrees of freedom is defined as the number of independent coordinates required to specify the complete configuration of the system. Here, there are two important terms are there. The number of independent coordinates and complete configuration of the system. So these two, based on, if we understand these two terms, we can define easily and we can understand easily the degrees of freedom of any body, whether it in the space or in planes. Here, we are going to discuss about when the body is in space. Here, a cube, in this figure we can understand, a cube is having the degrees of freedom, then the cube is in the space. When this cube is in space, with respect to the Cartesian coordinates, the coordinates are axis x and axis y and axis z. So this body having independent motions, 6 independent motions. What are they? It can be having 3 translatory motions, three translations about axis x, axis y and axis z, and 3 rotational motions about these axes. That's why there are 6 motions. That's why this rigid body possesses 6 degrees of freedom. So the degrees of freedom, another definition is called, suppose if this body is having restraint about axis x, restraint about axis x, it is a restraint about axis x. That means how many degrees of freedom? That is 5 degrees of freedom. 5 degrees of freedom can be this body can have. Suppose it is similarly, there are 2 constraints or 2 restraints motions about axis x, translatory motions about axis x and axis y. Axis x and axis y having constraint motions. That constrained motions are translatory motions are about axis and axis y are constrained or restrained. That means 6 minus 2. It may be having 4 degrees of freedom. Suppose this body is having, when the body is having the 3 translatory motions, 3 translations were constrained, then the degrees of freedom for that body is 3. Those 3 are 3 rotational motions. Similarly, that means from this we can understand the number of degrees of freedom equal to 6 minus number of restraints. 6 minus number of restraints. Now, here, if suppose in this subject, in kinematics of machines, we study only the plane bodies, 2-dimensional bodies. It is not 3-dimensional. Now, this classification of kinematic pairs based on number of restraints and number of constraints. So, in before lecture, we studied classification of kinematic pairs based on nature of contact, nature of constraints, nature of motion, whether it is sliding motion or nature of contact. Nature of contact means there is a higher pair and lower pairs. Another nature is called open pair and closed pairs. And another nature of motions, that is sliding motion or between 2 pairs. Now here we are going to study depending upon the number of restraints imposed on the relative motions of the 2 links connected together. A pair can be classified as given in table. This is the table 1.11, which gives the possible from each one of them. So figure A, we can understand here we can understand the degrees of freedom of figure A. In this figure A, this is axis X, axis Y, and axis Z. It is constrained or restrained of translation motion in Z direction. That means the number of degrees of freedom for figure A is 5. And coming to figure B, what is the degree of freedom for figure B? It is again in the figure B. Yes, we can see in axis X there is a motion, both the translation and rotation. In axis Y also both the translation and rotation. Axis Z, there is no translation, only about axis Z it is rotation. It is again 5. Now, figure C, if you see in figure C, in this figure, the motion with respect to the motion of the cylinder with respect to the link 1 is, what is the degrees of freedom? No translatory motion and no rotation on axis X. Only what is the degrees of freedom? And there is no translation motion in axis Z. So what is the degrees of freedom? 1, 2, 3, 4. This is the 4 degrees of freedom. Similarly, thus we can understand based on the nature of restraints, depending on the number of restraints, we can define various degrees of freedom of various bodies. If you understand, finally, we can see in this figure J. So what is the degrees of freedom? The degrees of freedom between link 1 and link 2 is only one single degree of freedom. It is completely constrained. It is completely constrained of translation motions about axis Y and axis Z. And also all rotational motions are constrained. So it is only possible way of the motion, the relative motion is only, it is a translation about axis X. That means what is the degrees of freedom? 6 minus number of restraints. That is single degree of freedom. So this figure J is completely constrained motion. So all completely constrained motions are having, what is the number of degrees of freedom? It is single degree of freedom systems. Based on restraints, there are different rotary motions, and this is nature of restraints. Depending upon nature of restraints, there are different classification of kinematic pairs are there. That is class 1, class 2, class 3, class 4, class 5, class 6, and so on. So the point is that here is the number of restraints. Okay, if it is only single degree of freedom, depends upon the degree of freedom concept, we divided kinematic pairs into different classes. So here this slide shows classification of kinematic pairs. Suppose in examination they ask explain the classification of kinematic pairs. There are 2 ways of giving answers. Number of ways are there, but here there are 2 ways of giving answers. So classification of kinematic pairs based on number 1, nature of contact, and number 2, nature of arrangement of 2 pairs. Arrangement of 2 places, that is open and closed. And number 3, nature of relative motion. Relative motion between 2 pairs. That is, this is one way of giving answer. The another way of giving answer is that based on the number of restraints. So based on number of restraints, class 1, class 2, class 3, class 4, we can explain. Next, what is kinematic chain? So far we covered degree of freedom, introduction. Now to find out the degree of freedom of various mechanisms or various kinematic chains, we have to understand what is kinematic chain. So a kinematic chain is an assembly of links in which the relative motions of the links is possible, and the motion of each relative to the other is definite. We should be having a definite. This definite is the key word, definite. But the motion should be relative. Once again, read it again. A kinematic chain is an assembly of number of links or number of elements in which the relative motions of the links is possible, and the motion of each relative motion to the other is a definite motion. It is not indefinite motion, it is a definite motion. So here in this figures A and B, C, D, E. So figure A is how many links are there? 1, 2, 3, 4. This is a 4-link mechanism or 4-bar mechanism. Next, in figure A, all links are binary links. So how many number of links are there means we are going to consider only binary links. So there are 4 binary links are there. Or how many joints are there? 4 joints are there, but all are binary joints. Now coming to figure B. In figure B, how many links are there? 1, 2, 3, 4, 5 and 6. It is a 6-bar mechanism or 6-link mechanism. But how many total number of binary links? So please understand here, there are 2 ternary links are there. These are the 3 nodes are there. 2 ternary links. 1, 2, 3, 4. 4 binary links and 2 ternary links. Okay. Now next, in this figure, if you understand how many binary links are there in figure C, if you observe, and how many ternary links are there and how many quaternary links are there. This is only one quaternary link, only one ternary link. These are all binary links. What is the binary link? 1, 2, 3, 4, 5, 6. There are 6 binary links, 1 ternary, 1 quaternary. But here, please pay attention. The binary links are different from joints. Now, how many ternary here? This joint is a ternary 1, 2, 3. This is a ternary joint. Now it is binary joint. It is binary joint. It is binary. Binary joint. It is binary. It is binary. Binary. So here only one ternary joint, remaining all are binary joint. The joint is entirely different from link. It is the joint is the node where number of links are connected. If the 2 links are connected at the joint, then it is known as binary joint. If 3 links are connected at the node, then it is called ternary joint. If 4 links are connected at the joint, then it is quaternary joint. Binary joint, ternary joint, quaternary joint. Joint is entirely different from the link. Joint is the joining, is the node where all links are met, joined, then it is joined. So now it can become in this. I said quaternary link. The link is different. The link is these, the 4 nodes are there. In kinematics, the joint is defined. For binary joint is defined with 2 nodes like a straight line. Ternary joint, it can become ternary joint, but the difference is that it will be hatched representation. Now it is the ternary joint. If you see in the quaternary joint, we can see here the quaternary joint. There are 4 nodes are there, but 4 nodes are completely hatched. There is no relative motion among these 4 nodes or links. Okay, no, 4 nodes. It is completely that is a quaternary link. Now, what is linkage? What is mechanism and structure? A linkage is obtained if one of the links of a kinematic chain. A linkage is obtained if one of the links of a kinematic chain is fixed to the ground. If the motion of any of the movable links results in definite motions of the others, the linkage is known as a mechanism. What is linkage? A linkage is obtained when one of the links of a kinematic chain is fixed to the ground, then it is known as a linkage. But if the motion of any one of the movable links results in definite motion, then it is called a mechanism. So here mechanism, what it does, mechanism, it transmits and modifies motion. And the distinction between mechanism and a linkage is hardly, what is that? It can be, you can understand, we can see in the following. So if one of the links of a redundant chain is fixed, it is known as a structure or locked system. If one of the links of a redundant chain, what is the redundant chain is fixed, it is known as a structure or locked system. To obtain constrained or definite motions of some of the links of a linkage or mechanism, it is necessary to know how many inputs are needed. What is the input here? How many inputs means it can become input angular motion or input linear motion. That is our angular displacement. Now, for what is locked system? For locked system, the degrees of freedom is 0. Suppose if there are 3 links are there, link 1, link 2, link 3. Now, if you fix it this kinematic chain, then it is called a linkage. And if you give some angular displacement or angular velocity to the link 2, there is no motion to the link 3. It can't be transferred. Why? It is a structure. The degrees of freedom of link 3, the 3 links is 0. Then it is called a locked system or structure. So a structure with negatives of freedom is there, then it is called a superstructure. So we will see in the coming slides how to calculate the degrees of freedom of various mechanisms, and we can validate this locked system, whether it is a structure, what is the degree of freedom is 0, which is in physically by observing you can see it. But if you want to validate through formula, that is Groupless criterion is that Groupless criterion. The degrees of freedom equal to 3 into L minus 1 minus 2J minus H. L indicates the number of links. What is the number of links here? The number of links are 3. What is how many joints are there? 3. How many higher pairs are there? Higher pairs are 0. Substitute here 3 minus 1, 2 times J joins 3 minus 0. Then what is the degrees of freedom of this 3 links kinematic chain? It is 0. That's why 3 links kinematic chain or 3 links of kinematic linkage is degrees of freedom of this 3 links mechanism is 0. That's why it is called a structure. It is completely locked. Now, mobility of a mechanism. The mobility, another name of degrees of freedom, is known as mobility. So, a mechanism may consist of number of pairs belonging to different classes having different number of restraints. Okay, now it is also possible that some of the restraints imposed on the individual links are common or general to all the links of a mechanism. So according to the number of these general or common constraints, a mechanism is divided into different orders. That is called zero order mechanism. A zero order mechanism will have no such general restraints. Okay, this is based on second order. Okay, second order is having two general restraints and so on, and up to the fifth order. A sixth order mechanism cannot exist because since all the links become stationary and no motion is possible. So based on the number of restraints, this is a first order mechanism or second order mechanism. So in first order mechanism, one general restraint. So for first order mechanism, what is the degrees of freedom? One restraint means it is the 5 degrees of freedom. Second order, 6 minus 2, 4 degrees of freedom. Third order, 6 minus 3, this is the 3 degrees of freedom system, third order. Fourth order is 2 degrees of freedom system. Fifth order is single degree of freedom system. Can it be exhaustible sixth order system? Then sixth order system, what is the degrees of freedom? Is 0 degrees of freedom. Then this sixth order system is degrees of freedom system is known as structure. That means degrees of freedom is structure, 0. No degrees, no motion, no relative motion is possible. Now, for a space expressing the number of degrees of freedom of a linkage in terms of the number of links and the number of pairs connections of different types is known as number synthesis. So, degrees of freedom of a space, when the body is in space, what is the degrees of freedom for that? So, the degrees of freedom when the body is in space, for that the formula is F equal to 6 times n minus 1, the number of links minus 1. This minus 1, why we are making? The number of links we are making, one of the link is fixed, okay? That is 6 into n minus 1 minus 5p1 minus 4p2. This is p1, p2, p3. So this p1 is means number of pairs having single degree of freedom. P2, number of pairs are having 2 degrees of freedoms. P3, number of pairs are having 3 degrees of freedom. P4, number of pairs are having 4 degrees of freedom. Like that, now 6 into n minus 1 minus 5p1 minus 4p2 minus 3p3 minus 2p4 minus p5. This is the formula for a body having, when the body is in space. Okay, that is, this is the formula we can use when the body, the degree of freedom of a mechanism in space can be determined by using this formula. But in our kinematics of machines, we will study only when the bodies are in two-dimensional or planes. So we can understand criterion, Groupless criterion. So here for a plane mechanisms, the following relation can be used to find the degrees of freedom. The degrees of freedom is that here for a Groupless, this criterion is known as Groupless criterion. What is Groupless criterion? Is indicates that is for two plane mechanisms. Okay. So in plane mechanisms, what is happening? This P1 is number of joints and 1P2 is the higher pairs contact. So 3 into n minus 1 minus 2P1 minus 1P2. Now, what is it for degrees of freedom in which each movable link possesses how many degrees of freedom? 3 degrees of freedom. Okay, that is what Groupless indicates, this formula. So each pair with 1 degrees of freedom imposes, if 1 degrees of freedom total is 3. If one pair is having 3, suppose 2 restraints are there, what is the degree of freedom for that? If it's 2 restraints are there, means there is 1 single degree of freedom. It is 1 degree of freedom imposes 2 further restraints. Thus, we can understand here, this is the Groupless criterion formula. Now, what is, and one more thing, the above relation, this relation is also known as Kuchbek criterion and is further simplified into F equal to 3 into n minus 1 minus 2p1. That means Kuchbek criterion number of higher pairs are 0. Okay, that is P2 equal to 0. Then for it is for a single degrees of freedom, what will happen? 3 into n minus 1 minus 2p1. Thus, we can understand the degrees of freedom concept of space when the body is in space and for a plane mechanisms. Now, this is the Groupless criterion as I explained in a scrutinizingly before. So, the number of degrees of freedom of a mechanism is given by, that is 3 into n minus 1 minus 2l minus h or 2j minus h. So, F is the degrees of freedom, n indicates the number of links in the mechanism, where j is the number of lower pairs or number of joints, where h is number of higher pairs. So, by substituting this formula, Groupless criterion is only meant for plane mechanisms. So, we can see furthermore what is how the number of degrees of freedom P2 equal to 0, how that formula is transferred into the single degree of freedom formula, that is F equal to 3 into n minus 1 minus 2p1. So if we further simplify it, suppose this formula is meant for single degrees of freedom systems, then degree of freedom equal to 1, substitute, then we can find out the relation between number of pairs and number of links. That's 2p1 equal to 3 into n minus 4. That is 1 equal to 3n minus 3 minus 2p1. Now 3n minus, that is 2p1 goes, this 3n minus 4, this 1 comes to right side, then 3n minus 4 equal to 2p1. 2p1 equal to 3n minus 4. This p1 and n are two whole numbers. If we know number of links, if n equal to 4 or if n equal to 1, if n equal to 1, and this formula if we substitute, p value how it comes? 3 into 1 minus 4 by 2. Minus 1 by 2, that is minus 0.5. That is number of pairs is not possible. So if n equal to 4, it will begin with, because 4 bar mechanism, suppose if n equal to 3, substitute in that formula, then 2p1 equal to 3 into 3 is 9 minus 4. That is p1 equal to 5 by 2. That is 2.5. Okay, next, if n equal to 4, then p1 becomes 4. That is no excess turning pairs. If n equal to 6, p1 equal to 7, one excess turning pair. Like that we can find out the number of turning pairs by substituting the number of links in the place of n in this formula. So this relation indicates, in some of the textbooks they found out the degrees of freedom based on number of links and number of pairs. Okay, in Ratan textbook they followed different mechanism like number of pairs, number of loops. Based on number of loops, what is L indicates number of loops. This is the formula. It is this formula only available in Ratan textbook. He found out a novel method to find out the degrees of freedom of any mechanism, but there is some certain limitations are there. By using this formula, suppose there is no loop is there, we can't find out. So it is only applicable for some of the mechanisms which consists of number of loops. Okay, this is what he used. So what is a redundant link? You can understand further more and more. So what is a redundant link? Redundant link means sometimes a system may have one or more links which do not introduce any extra constraint. Such links is known as redundant. Why it is redundant? Suppose, and that redundant link should not be considered to find out the degrees of freedom. So for example, in this figure 1.6b has how many links are there? 1, 2, 3, 4, 5. 5 links are there. But the function of the mechanism is not affected if any one of the links 2 and 4 are removed. Either 2, 4, 5 are removed. Any 2 or 4 or 5. If you remove it, it doesn't affect the function of the mechanism. So the effective number of the links in this case, how many are there? Doesn't affect me if any one of the link is removed. Either 2 or 4 or 5. Then what is the number of links in this mechanism? It is the 4. Though in this case, how many turning pairs are there? 4 turning pairs. So what is the degrees of freedom? It is 1 degree of freedom. How it is 1 degree of freedom? Number of links L equal to 4, J equal to 3 into L minus 1, 4 minus 1 minus 2J minus H. Here H equal to 0. Then what happens? 3 into 4. 3 is 9. 3 into 4 minus 1. Number of links 3 into 3 minus 2 into J. What is how many joints are required? 2J. From this we can calculate number of joints equal to 4. If J equal to 4, 3 into 3 is yes. If J equal to how much? If J equal to 4, then substitute over, then it becomes single degree of freedom equal to 1. It is a single degrees of freedom. Okay, to understand better, number of links or number of joints are 4. This is a 4 bar mechanism. In the 4-bar mechanism, yes, I'll explain here. Link 1, 2, 3, 4. Number of links L equal to 4. Number of joints 1, 2, 3, 4. Substitute in the formula of Groupless Criterion 3 into L minus 1 minus 2j. What is that 3 into L minus 1? 3 times. L is 4 minus 1 minus 2 into 4. What is that? 3 into 3, 9 minus 8. That equal to 1. The degrees of freedom of 4-bar mechanism is 1. So, it is written in further explanation. There is a contact between 3 and 2. Link 3 and 2. It doesn't affect the motion of the link 3 when it is under link 2. So, it is also redundant degrees of freedom. So, by considering the redundant degrees of freedom, the formula of degrees of freedom of any mechanism is F into 3 into n minus 1 minus 2p1 minus 1p2 minus Fr. This Fr is a number of redundant degrees of freedom. If we understand in this mechanism, if we see in RS Kurmi, you will find out only maximum of, yes, redundant degrees of freedom also covered, but this much clarity we won't get it. Now, that here how many links are there? Link 1, all fixed links are considered 1 link, 2, 3 and 4 links. These are 4 links are there. How many joints are there? There are 3 lower pairs are there. That is 3 lower pairs, 2 into 3. Number of links are 4, 3 into 4 minus 1 minus 2p1. That is number of lower pairs. That is 2 into 3. How many higher pairs are there? Single higher pair. What is the higher pair? If there is the contact between two links is either point contact or line contact, then it is considered as higher pair. That is single higher pair. What is the redundant degrees of freedom? The redundant degrees of freedom is 3 and 2 between. Again, 1. If you substitute here, 3 into 4 minus 1, 9 minus 6 minus 1 minus 1. That is single degrees of freedom system. This mechanism is a single degrees of freedom system. Okay, here that is the final formula to find out the degrees of freedom. So here I used 3 into L minus 1 formula minus H minus Fr. That is the final degrees of freedom formula by considering including redundant degrees of freedom. So I also shown here 3 into n minus 1 minus 2p1 minus 1p2 minus Fr. This joint is a single degrees of freedom. Okay, understand? How many constants are there? There is single constant. This is the lower pair. This P2 indicates, H indicates higher pair. The both formulas are same, but notations are different. Now, we are going to study some of the examples of degrees of freedom. Okay, it is a 4 degrees of freedom. That is F equal to 3 into n minus 1 minus. Here joints are lower pairs. L indicates lower pairs. That is the same formulas. I am using 3 into n minus 1 minus 2 times lower pairs minus higher pairs. You can follow any notation, but the concept remains the same. That is 3 times number of links minus 1 minus 2 times lower pairs minus 1 time higher pair minus number of redundant degrees of freedom. Now in this mechanism, in the 4-bar mechanism, the number of links are 4, n equal to 4. The number of lower pairs, that is joint, that is a surface contact between the two links, it is considered as a joint. That is the number of lower pairs are 4. And in this mechanism, there is no point contact or line contact between the two links. That's why higher pair equal to 0. And also there is no redundant degrees of freedoms. That's why Fr equal to 0. Substitute over here in this formula, then what is the degrees of freedom it will be obtained is only single degrees of freedom. What is that meaning? What is the significance of single degrees of freedom? If we give motion to one input to any one of the link, will result in a definite motion of all the links. That means it is completely constrained motion. It is completely constrained motion in spite of giving the forces in different directions. It gives only one input, definite motion. If you give any one input to any one of the link, any one of them means if you give input to two links, now link 3, or if you give input to link 2, if you give input to link 4, it gives definite motion. Okay, any direction, either clockwise or anti-clockwise, it gives a definite motion to all other links. That's why it is called a single degrees of freedom. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.